Hi all. In this video, I'm going to show you some of the examples for Fourier series on how to write Fourier series in terms of trigonometry series and also in terms of complex exponential form. Okay, let us see the first example. Given the signal Vt as below, using Euler's theorem, obtain the signal in exponential form and determine the complex Fourier coefficient. So there are two questions here. First, you have to obtain the signal in the exponential form equation. Then you have to take out the complex Fourier coefficient and determine the complex Fourier coefficient. Okay, for this question, first, you recall back the Euler's theorem. Okay, for Euler's theorem, we have cos theta equal to exponent j theta plus exponent negative j theta divided by 2. And for sine theta is equal to exponent j theta minus exponent negative j theta divided by 2j. Okay, using this Euler's theorem, you can replace the equation for cosine and also sine here into Vt. Recall that in my class, I said that you can also change sine equation here into cosine equation. However, for this example, I'm going to use straight the Euler's theorem for sine theta and cos theta and put into the equation. So here it will become like this. And recall back for the complex exponential, the relation with the phase is j equal to pi over 2 or negative j is equal to negative pi over 2. So you can simplify this equation into this equation. So again, simplify from here to here. Okay, for example here the sinus part 4 divided by 2j, so when j bring up here it will become negative j. Okay, so for this part this is a negative 2j. Okay, negative 2j for the exponent j3 omega naught t and positive 2j for the exponent negative j3 omega naught t. Okay, because negative it becomes positive. You rearrange so that you rearrange from the negative part, the smallest negative, okay, and then to the biggest positive number in terms of the frequency. So it will become equal to 2 exponent j pi over 2 exponent negative j3 omega naught t. So this exponent j pi over 2, okay, refers to this. Okay, recall the equation here, j is equal to pi over 2. So j here is actually exponent j pi over 2. Okay, so from here it become like this, right? And then plus 2.5 exponent negative j 30 degrees multiplied by exponent negative j 2 omega naught t, which is from this. Okay, from this to this. All right, sorry, here we have 2.5. Actually we have 2.5 here. All right, and then plus 1.5 exponent negative j omega naught t, and then plus 10 plus 1.5 exponent j omega naught t plus 2.5 exponent j 30 degrees. Okay, this is the positive part, multiplied by exponent j to omega naught t. So this is from here, right? And then plus 2 exponent negative j pi over 2 exponent j 3 omega naught t. Okay, and this is from here. So you notice that this is negative, so we put negative j here as negative pi over 2. So in terms of exponent, it will become exponent negative j pi over 2. Okay, so this is the equation in terms of exponential form. So you have answered now the first question. to determine the complex Fourier coefficient. Okay, so we do it in on the next page here. I already rewrite the equation that we obtained. So from here you can extract the Fourier series complex coefficient. You write in terms of the table. Okay. Okay, in order to extract the Fourier series complex coefficient, you put in the table up until the n equal to 3, because in the equation here n is up to 3, okay, at 3 omega naught t. Okay, so you put like this. So from here you take the values for n equal to 0. N equal to 0 is actually referred to 10 because it doesn't have any frequency. So you put here 10, there's no negative part, and then n equal to 1, this is 1.5, okay, which refers to this equation. And then for c negative n, it should be 1.5 as well, okay, because this is conjugate. And then for n equal to 2, this one is 2.5, and for this component it has degrees 30. Okay, so this one refer to here. And then for the negative part, okay, you take this part, which is 2.5. However, it has negative 30 degrees as its face. For n equal to 3, this one is 2, okay, which is from here, okay, and then the value of the phase here is negative pi over 2. So negative pi over 2 is actually negative 90 degrees, okay, because pi equal to 180 degrees. So c negative n for n equal to negative 3 is also 2, okay, which is this part here, and this is the phase is 90 degrees. So from here you can also plot the spectrum. Okay, so when we want to plot the spectrum, even though the question didn't ask you to plot the spectrum, I'm going to show you how to plot the spectrum from this table, Fourier coefficient table. So this is n. So you plot in terms of magnitude of Cn. So here we have n from negative 3, negative 2, negative 1, 0, 1, 2, 3. When n is equal to negative 3, the magnitude here is, okay, you take this part, is 2. Okay, when negative 2 and is equal to negative 2, this is negative, this is 2.5. And then when n equal to negative 1, this is 1.5. Okay, so when n equal to 0, this one is 10. Okay, 5, 5, and also 2. So this is the spectrum plot for magnitude, and another one you have a spectrum plot for phase. Okay, so for phase, plot against the n. Okay, we have for n equal to negative 3, negative 2, negative 1, 0, 1, 2, 3. N equal to negative 3, you refer back here, 3. So C negative n means the negative part. The degrees here, or the phase here, is 90 degrees. Okay, so you plot 90 degrees. Okay, for negative 2 is 30 degrees, which is this part. Negative 30 degrees. For negative 1, there is no phase, so no plot here. And for 2 here is 30 degrees. And for 3 here is negative 90 degrees. So this is what it meant by conjugate, okay, where the magnitude is the same and the phase here is different, or it can be vice versa as well. Question here, for example 2, determine the complex Fourier coefficient for the signal given below. Sketch the double-sided spectrum for this signal. So this question is similar to example 1, where you have to use Euler's theorem. So you put Euler's theorem here, so you can directly the cosine or the exponential function for cosine into the equation. Okay, so like I said before, this is included in the list of formula. However, it will be easier for you if you can memorize this, right? Okay, so you put into the equation, it will become 1 plus, for the sine, you put the sine, and for the cos, you use the cosine. Okay, now I have rewrite the equation here in terms of complex exponential by using cosine and sine theta for the exponential function based on Euler's theorem. So from here, okay, sine is this one, cosine is this part, and cosine to omega naught t plus pi over 4 is this part. Okay, so from here you simplify the equation, become 1 plus 1 2j exponent j omega naught t for this part, and then minus 1 over 2j exponent negative j omega naught t plus by 2 is 1, so it becomes exponent j omega naught t plus exponent negative j omega naught t plus 1 over 2 exponent j 2 omega naught t plus 4 plus 1 over 2 exponent negative j 2 omega naught t plus pi over 4. Okay, so it become like this. Based on this equation, did you notice that we have the same part of frequency, okay, for this one exponent j omega naught t, and this one exponent j omega naught t, and this one as well exponent negative j omega naught t. Okay, so you rewrite this equation so that you put together the one with the same frequency. So from the previous page, the equation for Vt will become Vt equal to 1, okay, which is at the part n equal to 0. So for n equal to 1, you put together 1 plus 1 2j exponent j omega naught t, and then the negative part 1 negative minus 2j exponent negative j omega naught. And then for n equal to 2, 1 over 2 exponent pi over 4 exponent multiplied by exponent j to omega naught t, and finally plus 1 over 2 exponent negative j pi over 4 exponent is negative j to omega naught t. You can further simplify this. However, the question asks you to find the complex Fourier series coefficient for signal. So you can straight take the coefficient from this equation. Draw the table for n, for c negative n, which is the negative part of the Fourier series coefficient. So we have 0, 1, 2 only. Okay, 2. And then for the equation here, we'll put the value when n equal to 0, cn equal to 1. There's no value for c negative n. For n equal to 1, which is this part, we put 1 plus 1 2j. So this one is actually 1 minus j over 2. Okay, because 1 over j is equal to negative j. So this is basically a rectangular number. You can change it to polar number. Please again revise for this part. You can change by using calculator also. So the value here for the phase here is negative 0.57 degrees. Okay, for the negative part, you take this one, 1 minus 1 2j, which is equal to 1 plus j over 2. Okay, so if you change to the polar number, it will give you the magnitude 1.12 with the phase 26.57 degrees. For n equal to 2, you take from here, okay, this one is 1 over 2 exponent j pi over 4, okay, which is also equal to 1 over 2. So pi over 4 is 180 divided by 4, 45 degrees. It's 1 over 2 exponent negative j pi over 4. So become 1 over 2 negative 45. So from here, you can plot the spectrum for the magnitude and also for the phase. So for the magnitude, you plot again n, okay, because you want to plot the magnitude in terms of the Fourier coefficient. So this one is n, and from negative 2, negative 1, 0, 1, and 2. Okay, for negative 2, the value of the magnitude here is 0.5, 1 over 2, which is 5. For negative 1, it is 1.12. and then 1 for 0, 1.12 for 1, and for n equal to 2, this is 0. Okay, so this is the plot of the magnitude, and another one is the plot for the phase. Okay, so it involves negative part. So for negative 2, sorry, this is 1. This is 2, the degrees here is negative 45. So this is negative 55. If 1, here is it is 26.57 degrees. For 0, there is no phase involved. For 1, it is negative 26.57 degrees, and for 2, it is 45 degrees. So again, you can see the conjugate properties for this Fourier series equation. This is for the phase. Right. So example 3, a signal GT is given in the figure below. The Fourier series for GT is given by this one. Okay, this is a equation that is given to you. However, if this equation is not given to you, it is actually in the table, okay, in the list of formula. So this is the signal GT. So first you need to find a double-sided spectrum for the signal until fifth harmonics. It means that you need to find the equation in terms of Fourier series complex exponential first. Okay, because in order to plot double-sided spectrum, you need to have complex exponential equation first. The second one is sketch a single-sided spectrum. So this one, it can be, you have to find the trigonometric equation first. Okay, so this one, you have to find the complex exponential form of the Fourier series. Okay, so this is only based on this graph. And this one, you have to find the trigonometric equation, okay, for Fourier series. Okay, and then this, if you see this shape of the signal, and from the table of Fourier coefficient here, this is actually sawtooth. Okay, sawtooth. So it is given here the equation for complex coefficient. For example, for C0 is when n equal to 0. Okay, the equation is x0 over 2. So x0 is the magnitude of the sawtooth here. And then for Cn, for any n except for n equal to 0. So it can be n1, 2, and so on. This is the equation. J x0 divided by 2 pi n. So it depends on the n. If n equal to 1, you replace 1. Okay, x0 here is the magnitude. So for this equation, we use this equation. Okay, and notice also in the example here, in the question here, it already stated the equation, which is actually the same as in the formula. Okay, but if the equation here is not given, refer to this formula in the table of Fourier coefficients. Okay, so now let us solve this. Okay, so first you have to plot the double-sided spectrum. So you use the equation given. So I rewrite the equation given here. x0 over 2 plus summation of n equal to negative infinity to infinity for n not equal to 0. x0 over 2 and pi exponent j pi over 2 exponent j n omega naught t. Okay. So x0 here is given as x0 as well, and t0, okay, x0 here is also given as x0, and t0 is also given as t0. The question asks you to find for the single-sided and also double-sided spectrum up until fifth harmonics. And given the equation here, you can find the Fourier series coefficient up until n equal to 5. So 0, 1, 2, 3, 5 for both positive and also negative part. Okay, so for n equal to 0, this one should be x0 over 2. For n equal to 1, you put n equal to 1 in the equation here. Okay, it will become x0 divided by 2 pi exponent j pi over 2. For C, negative n, and n equal to negative 1, it will become x naught divided by negative 2 pi, because n equal to negative 1, and this one become exponent j pi over 2. However, using the complex coefficient relation in the graph, the one that I asked you to revise, okay, negative pi here you can bring in terms of exponential, it become exponent negative pi. So this one will become equal to x naught over 2 pi exponent negative j pi exponent j pi over 2. Okay, so exponent multiplied by exponent, you can simplify further. So this one will become x naught over 2 pi exponent negative j pi over 2. Okay, because negative pi plus pi over 2, it becomes exponent negative j pi over 2. Okay, this is for n equal to 1. And then for n equal to 2, you put n equal to 2 in the equation. So this one will become x naught over 4 pi exponent j pi over 2. So similarly for this one, it will become x naught over 4 divided by 4 pi exponent negative j pi over 2. Okay, so the same way on how I get exponent negative j pi over 2. So it is the same here. For n equal to 3, this one is x naught over 6 pi exponent j pi over 2. So if you see here, this is quite a lengthy equation. So you have to be careful not to do any careless mistake here. This one is x naught over 6 pi exponent negative j pi over 2. Okay, so for n equal to 3, then n equal to 4, x naught divided by 8 pi. X naught divided by 8 pi as well, but the face is negative. Okay, and finally for n equal to 5, x naught divided by 10 pi exponent j pi over 2. X naught divided by 10 pi exponent negative j pi over 2. Okay, you can rewrite the equation, okay, in terms of complex exponential form. Okay, however, the question asks you to only plot the double-sided spectrum. Okay, they didn't ask you to rewrite the equation. Okay, so I'm going to rewrite the equation here for you. So here gt will become x2 plus, okay, take this part, x naught divided by 2 exponent j pi over 2, and then when you rewrite the equation, then only you take this part, okay, multiply by exponent j n omega naught t. So for n equal to 1, this one will become exponent j omega naught t. Okay, the frequency component for n equal to 1, and then plus this x naught divided by 2 pi exponent negative j pi over 2 exponent negative j omega naught t plus x naught over 4 pi, and you write up until here. Okay, up until n equal to 5. Okay, now I already rewrite the equation from n equal to 1, from n equal to 0, 1, 2, 3, 4, and 5, and put also in the equation the frequency involved. Okay, so what you have to do is just replace n here, obtain the Fourier coefficient, and replace n here so that you can put into the equation of Fourier series complex. Okay, Fourier series complex exponential. And now we want to plot the double-sided spectrum for the signal until fifth harmonic. So first we plot the magnitude. So here you can plot against n. When you plot against n, you put n equal to negative 5 up until 5. Or if you want to plot against omega here, okay, so when you label here negative 5 omega naught, negative 4 omega naught, negative 3 omega naught, negative 2 omega naught, negative 1 omega naught, 0, 1 omega naught, 2 omega naught, 3 omega naught, 4 omega naught, and 5 omega naught. Okay, so the value here for n equal to 0 is x naught over 2. Okay, and of course when n equal to 1, the value here is x naught divided by 2 pi, so it will be the value will be less than x naught over 2. Okay, and the drawing should be something like this. Okay, should be symmetrical symmetrical at n equal to 0. Sorry about the bad drawing. Okay, I hope you can draw better. And then you label here x naught over 2 pi, x naught over 4 pi, x naught pi, x naught over 8 pi, and finally x naught over 10 pi. Okay, so this is for the magnitude. And then we have another plot which is spectrum. Okay. Spectrum also involve up to a fifth harmonic. Okay, 53 omega naught, 84 omega naught, 85 omega naught. Let's draw this better than me. Okay, so the value here for the positive part, if you refer back here, okay, the phase here for the positive part all are 90 degrees. For the negative part all are negative 90 degrees. Okay, the drawing something like this. This one is pi over 2 or 90 degrees. 5. This one should be the same. Okay, so now you already answer the double-sided spectrum. And now we move to another question here. Okay, recall back the question, ask you to sketch a single-sided spectrum. So from this equation, you need to put in terms of trigonometry series. All of this equation into the trigonometry series. So let us write one by one. First, you have to recall back the Euler's theorem, where you have to use cos theta equal to exponent j theta plus exponent negative j theta divided by 2. Okay, so use this one. Right, so I'm going to write again the equation in terms of complex exponential for you. Okay, now I have rewrite the equation for you in terms of complex exponential form. We need to use this Euler theorem to turn this equation into trigonometry series. When you change it into trigonometry series in terms of cosine or sine, then only you can plot the single-sided spectrum. Okay, we write 2 x naught over 2, which is n equal to 0 part, and then for n equal to 1 part, you write here x naught over pi. Okay, you notice here the equation is x naught over 2 pi, right? So you leave 2 here in the big bracket so that you can match with this cosine. Okay, and exponent here become exponent j. Take out the j and put in the bracket pi over 2. Sorry, you put the omega naught part first. So it will become exponent j omega naught t plus pi over 2 plus exponent negative j omega naught t plus pi over 2. Okay, if you notice here, exponent multiplied by exponent, you can add up the function here, pi over 2, okay, plus omega naught t, you take out the negative j. Okay, so it become like this. And then you do for another part, which is n equal to 2. So for n equal to 2, you take out x naught over 2 pi, so that you can divide by 2 here. Okay, because 2 multiplied by 2 pi is equal to 4 pi. So for here, exponent, take out the j, inside the bracket will become 2 omega naught t plus pi over 2, and then here will become exponent negative j 2 omega naught t plus pi over 2. Okay, so notice that in order for you to match with the Euler's theorem here, inside the bracket must be the same. Okay, in terms of positive and negative, you cannot put like something like negative j 2 omega naught t minus pi over 2. Okay, because otherwise it will not be the same with this one. So you have to make sure that whatever inside the bracket is is the same because it is basically theta. Okay, that is why at the first place, before this, I changed the negative part here. Okay, so I put negative j pi over 2 instead of j pi over 2. Okay, remember where I take out the, or I change the part where negative j here into negative exponent negative j pi, and then plus negative j pi would become like this. Okay, so you do this for 3 more parts, which is n equal to 3, n equal to 4, and also n equal to 5. So now I have rewrite the equation for n equal to 0, and this is n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5. So this is quite a very long equation. Myself also, and also students tend to do some mistakes, and just now I've made some mistake here. It should be x naught over 10 pi. So if you notice some mistake here, please let me know. Okay, and from here you can match with the equation cosine here. So the long equation here will become equal to gt equal to x naught over 2 plus x naught over pi. So this is cosine cos omega naught t plus pi over 2 plus x naught over 2 pi cos 2 omega naught t plus pi over 2 plus x naught over 3 pi cos 3 omega naught t plus pi over 2. So this is n equal to 3, and then n equal to 4, x naught over 4 pi cos 4 omega naught t plus pi over 2, and finally x naught over 5 pi, and this one is cos 5 omega naught t plus pi over 2. Okay, so that is why you need to have the same number, and also whether it's positive or negative inside the bracket here, so that you can match with this equation. It will become, for example, here cos 5 omega naught t plus pi over 2. So in case one of these is negative and positive, you cannot replace it with cosine. Okay, you have to find a way to rearrange so that it will become the same within the bracket. Okay, the numbers and also the polarity within the bracket is the same. All right. Equation, we already obtained the Fourier series trigonometric form, and then from here you can plot in terms of single-sided. So for single-sided, it means that you have to plot only at the positive side, or you can take the value of the magnitude straight away. Okay, so single-sided basically is shorter, okay, in terms of equation and also in terms of the drawing. So this is x naught over 2 gt. Okay, right. So we have from omega naught, from omega naught, 2 omega naught, 3 omega naught, 4 omega naught, and 5 omega naught. So for 0 is x naught over 2. For omega naught, it is x naught over pi. Okay, so the line also becomes shorter as n increases. Pi, x naught over 4 pi, x naught over 5 pi. Okay, and we draw another plot, another graph for phase. Okay, so from omega naught up until 5 omega naught over 2. Okay, because we got from the equation, we obtained from the equation where the phase for all components for n from n equal to 1 up until n equal to 5, the phase here is pi over 2. Okay, this is the phase. So you draw for all n, the phase is pi over 2, and there is no phase for n equal to 0, or for omega equal to 0. So finally you answered the question to plot the double-sided spectrum and also the single-sided spectrum. Okay, basically, if you already know how to do it, you do not have to write this lengthy equation. Okay, but this is how you obtain actually the magnitude. Okay, basically what you can see here, from this magnitude, okay, for the double-sided spectrum, it has actually the magnitude has been divided by half compared to the single-sided. Okay, single-sided, which in which we have x naught over pi, x naught over 2 pi, and so on. For the double-sided, we have x naught over 2 pi, x naught over 4 pi, and so on. Okay, so if you notice here and you understand the relationship here, then you can use to check back your answer, or you can use to plot the graph straight away. However, you have to mention somewhere here that you understand the equation, the question, how you obtain from the double-sided to the single-sided spectrum, right? For signal xt is shown as in figure below. Given this signal or this waveform, by referring to the Fourier coefficient table, determine the complex Fourier series for this signal until the third harmonics, okay, which is shorter than before. The previous question asked you to write until fifth harmonic. This is a very long equation. And secondly, write the equation for xt in the form of trigonometric cosine Fourier series until the third harmonic. So first, you only have to determine the complex Fourier series coefficient. You don't have to write the equation for Fourier series complex exponential form. And then, based on the waveform given, and you refer to the table, this is square wave. Okay, for the square wave, C naught when n equal to 0 is 0, and Cn when n not equal to 0 is given as negative j 2 x naught over pi n, and x naught here is the amplitude, the highest amplitude. However, you have to notice at the comments. Here it means Cn equal to 0 for n even. It means that there is no value when n is even number. Okay, so don't be confused with these comments here. So the question asks you to find the Fourier coefficient when n equal to 0 up until n equal to 3. Okay, the third harmonics. It means that you have to ignore when n equal to 2, because n equal to 2 is even number. So when n equal to 2, there is no value for Cn. So you only have to find when n equal to 1, 3, and so on. But because the question asks you to do at until third harmonic, so you stop until 3 only. So if it asks you to do until 10 harmonic, then you continue to 1, 3, 5, 7, 9. Okay, so please notice the comments here. Okay, and then from here, we do the question, and we notice that x naught here is 2. Okay, x naught here is 2, and t naught here is t naught. Okay. Bila c naught equal to 0 when n equal to 0, and then Cn equal to negative j 2 x naught over pi n. Okay, when n not equal to 0 and n is odd number. So from here, you know that x naught is equal to 2. And then you draw the table for n, for Cn, and for C negative n. Negative n. For n equal to 0, there is no value, so you don't have to put in the table. For n equal to 1, okay, you put n equal to 1 in the value of this, it will become negative j 2 multiplied by x naught, which is 2. So this one is negative j4 over pi multiplied by 1 is pi. So you can also rewrite this as 4 over pi, okay, negative 90 degrees. We write for the negative part. So for here, it will become negative j4 over negative pi, because n equal to negative 1. So it's also equal to 4 over pi, and j here is already positive because we cancel out the negative. The degrees here is 90 degrees, right? So again, remember that j equal to over 2. Negative j is equal to negative pi over 2. Okay, so refer to the relationship of a complex exponential form here in the graph. So n equal to 3, this one is negative j over 4 divided by 3 pi. So this one become 4 over 3 pi, is negative 90 degrees, and this part will become, for n equal to negative 3, it will become like this. So now you have answered the first question, which asks you to determine the complex Fourier series for the given waveform up until the third harmonic. So for question number 2, you are required to write again the equation in terms of trigonometric cosine Fourier series up until the third harmonic. So I'm just going to solve it here. Okay, so it will become xt, okay, because the waveform is given as xt. So there is no component for n equal to 0, so you just take from n equal to negative 1 first, 4 over, or you can take from negative 3, so it's up to you how you're going to arrange the equation. So let's say I'm going to take from n equal to negative 3, so this is 4 divided by 3 pi, okay. 90 degrees here is actually the same as exponent j pi over 2. So this one will become exponent j pi over 2, and this one is for negative, exponent negative j 3 omega naught t. Okay. The positive part, so this one is plus 4 over 3 pi exponent, this one is negative j pi over 2 for n equal to 3, so exponent j 3 omega naught t. Okay, and then for n equal to negative 1, 4 over pi exponent j pi over 2 exponent negative j omega naught t plus 4 over pi exponent negative j pi over 2 exponent j omega naught t. And you rearrange this equation so that you can use the formula cos theta is equal to exponent j theta plus exponent negative j theta divided by 2, right? So that I can take out the j, 4 over 3 pi, this one become exponent negative j. I take out the negative j, so here it will become 3 omega naught t minus pi over 2, okay, and then plus 4 over 3 pi exponent, this time I take out the j only, so it become 3 omega naught t and minus pi over 2. Okay, so notice that I make sure that inside the bracket is has the same numbers and also polarity. Okay, and then plus 4 over pi exponent, take out the negative j, become omega naught t plus pi over 2, 4 over pi exponent j omega naught t minus pi over 2. Okay, so from here you can match the cosine equation here. So this one will become over 3 pi, you take out, and then you take the positive part, exponent j 3 omega naught t minus pi over 2, and then plus here exponent negative j 3 omega naught t minus pi over 2. So we need to have divide by 2 here so that we can match with this cosine function, Euler's theorem. Okay, so you can put divide by 2 here. However, when you put 2 here, then you also have to multiply this 2 here. Okay, plus 4 over pi, okay, in the bracket exponent j omega naught t minus pi over 2 plus exponent negative j omega naught t minus pi over 2. Okay, because you want to divide by 2 here, so you have to multiply by 2 the up here. Okay, so basically this will become, let me write on the left here, right here, this one here, so it will become 8 over 3 pi cos 3 omega naught t minus pi. Okay, and then we have the n equal to 1, so this one will become 8 over pi cos t minus pi over 2. Okay, so this is your answer for the trigonometric cosine Fourier series form up until the third harmonic. Okay, so you can rearrange to put this one at this side. Okay, the smallest n first, and then only the higher right. Examples I took from a previous past year either test question or final year question. Okay, so we have another example. Then in this example, it's actually a bit we call it a bit challenging. Okay, because normally we need to plot the graph, or we have to obtain the equation in terms of single-sided or trigonometric series or complex exponential form based on the given waveform. Okay, but for this example, the amplitude and phase spectrum for the signal is given in figure A and also figure B. Okay, it means that the question here give you the spectrum, and you have to match back the spectrum, or you have to write the equation so that you can determine the original form, or you can determine the equation in terms of the complex exponential form or trigonometric series from the spectrum. Okay, when I say spectrum, means that this is given in terms of the frequency domain. Okay, normally you are given signals in terms of time domain and you have to plot the frequency domain. But now this is the opposite case. And you have to find the complex exponential Fourier series for yt. Okay, because given here is y omega, which is in the frequency domain, and the trigonometric cosine Fourier series for yt. Okay, the complex exponential Fourier series. So I have redrawn the spectrum for you here. Okay, so from here you can take yt equal to, we know that this is a complex exponential form because this is a double-sided spectrum. So you have to write the equation in terms of complex double-sided form first. Okay, so first we look from the smallest frequency, which is negative 5 pi over 3. So this one you just take the amplitude, which is 0.5, and then multiply by exponent negative j 5 pi over 3. But however, you have to look here at the phase. Is there any phase here? And we measure for negative 5 pi over 3, there is no phase here. So you don't have to add any phase here. Just like that. Okay. T. And then plus. This one is 1 for negative 3 pi over 3. So you take exponent negative j 3 pi over 3t, and however for the phase you also have component, okay, at negative 3 pi divided by 3. So it means that here should be multiplied by exponent j 3 pi over 2. So don't forget the j. Okay, when you put from the phase here, don't forget the j. Okay, when you put from the phase into the exponential form, don't forget the j. And then actually we have 3 here at n equal to 0. So plus 3 plus exponent. Okay, take the positive part here. Okay, this is 3. Exponent j 3 pi over 3 t. And then for spectrum at 3 pi over 3, at omega equal to 3 pi over 3, there is a negative 3 pi over 2 phase. So You multiply here by exponent negative 3 pi over 2. Okay, so don't forget the j here. And then plus 0.5 exponent j5 pi over 3t, okay, for this part. Okay, for omega equal to 5 pi over 3. Right, so when you got this, okay, you rearrange back or you solve for the equation here, it will become 0.5 exponent negative j5 pi over 3t plus exponent negative j, take out the negative j, it will become 3 over 3 pi t minus 3 pi over 2. Okay, when you multiply back, negative multiply by negative, it become positive back. Okay, so we write back t minus 3 pi over 2 plus 0.5 exponent j5 over 3t. Okay, so now you already answered the first question, in which you have to find in terms of complex exponential Fourier series. So remember, when the question said complex exponential Fourier series, it means in terms of exponential form, and you can take it straight away from the double-sided spectrum. Okay, so this is the answer for question 1. Okay, you have to use the relationship, Euler's relationship, cos theta equal to exponent j theta plus exponent negative j theta divided by 2. Okay, so from the above equation, you can rearrange, okay, for the same omega. So first, yt equal to 0.5. Okay, you take from for 5 pi over 3 here. So here is exponent j5 pi over 3t. Okay, the positive part first. Plus exponent negative j5 over 3, 5 pi over 3 t. Okay, this part. Alright, so you have to divide by 2 in order to make it cosine. So when you divide by 2 here, you have to multiply 2 up here. And then plus, okay, you take the n equal to 1 here. This is plus. And then, because this is 1, sorry, it's 1. So this is exponent j 3 pi over 3t minus 3 pi over 2 for the positive part, and then for the negative part, exponent negative j 3 pi over 3t minus 3 pi over 2. So again, because you want to divide by 2 here, you have to multiply by 2, and finally you have to plus 3. Okay, so rearrange back the equation, okay, and use this Euler's theorem to replace this equation. Okay, we'll get 3. Okay, I put n equal to 0 first, plus, then I take n equal to the smallest after 3. So this part, this one, become 2 cos 3 pi divided by 3. Okay, it can become cos pi t minus 3 pi over 2, and then plus 0.5 multiplied by 2 is 1, so it becomes cos 5 pi over 3t. Okay, so now you have answered both questions, in which you have to find the exponential you have to find Fourier series in terms of complex exponential form, and the second one is you have to find the Fourier series in terms of trigonometric form. Okay, so remember, this is complex exponential form because it involves the exponent function, and for this one is trigonometric series form. Okay, why? Because it involves the cosine. This video tutorial, so I hope I can show you some more examples for the next videos. Thank you very much.